Hello, my name is Adarsh Pathak and I'll record the video for Causality Crash Course. So here's my objective to how the causality works in the machine learning model. And there is a difference between the correlation and the causation. So the main difference between the correlation is and the causation is that the correlation depends only on two variables and causation depends on multiple variables. So there can be three variables. So I'll give you an example by showing this blog. So here I have this, and like for example, if the person is sleeping wearing the shoes, then the reason could be might that he and she could be drunk, or he and she could have the possibility of sleeping, that he and she might be getting headache while on the sleep. So there is the two reasons for one prediction or one result. So here is the main definition of how the confounding variable works, and this is the main principle of how the causation model works. So I'll go ahead with the possibilities of how A is related to B is related to A, and then how they both can be related to each other via another variable, which is C. So we can make the predictions using the variable C as well. And moving ahead with this, we have the main difference between the correlation and causation. So I have also plotted some graphs based on which we can derive some features as well. So here is the sales of ice cream and the forest fires. So it goes high in the month of June to July till September, because at this time there is winters, and so there could be the case of fires as well. And next, I'll straight away jump into the part of coding. And so here I have also pasted the example of how this causation and correlation related to each other. So while the person is sleeping, then this could might be the reason of why there is a headache for this person. So I'll take an example of how this causation works. So I have taken an example of this adult data set, which so firstly I import the data set, install the casual inference, and then after that imported few of the libraries from the NumPys and Pandas and Matplotlib and Seaborn. So here is my data set, which I uploaded on the GitHub, and here are the few columns like age, work class, and education number, and the marital status. So it goes ahead with that, and here I have given the detailed description of uh, how the data set works, like what are the names of all those variables and entities are there. So these many columns I have, and these are the first five rows of my data set, and this is the last five columns of my data set. And then I did the pre-processing of my data, like how many counts are there, how many values are missing on my data set. So it goes like this, and using the predefined functions like data.count, so this will give me the count of the numbers that is already there in the data. And the describe gives me the detailed description of how the numbers are going into the mathematical function. So let's say there is a 25 percentile of the values and 75 percentile of the values, how they are going ahead with this, what's the maximum and what's the minimum of the numbers in the data set. And moving ahead with this is the main part. Like I have shown here the shape of the data. We have 32,561 rows and 15 columns. So this is the dimension of our data, and this is the basic information how the data, how our columns looks like, and how many numbers are there in our data set. So using this method, like data.is null sum, we have shown that there is zero values, that is there is no any missing values in our data set. And going ahead with this, we have removed all the duplicate values. Maybe there could be any or there couldn't be any, so we can also remove that duplicate value. So here I have written the function to how to remove that function, how to remove the duplicates, and I did the in place true to make this as a permanent change, not as a temporary change in our data set. And also, and then again we check with like whether the data is missing or not. So, and here we have filled our data. So we seen that the data was missing in our data set. So we have filled here using fill NA method, and only for these three columns, not for all of them. So we have only these three columns which has the null values, which is work, class, occupation, and the native country. And then this is all goes under the EDA process. And then the step 4 is label encoding. Label encoding usually done at the output stage. So here we have done the label encoding, and to convert all those things into the single numbers. And this is my EDA process, how it goes with this. So I have plot the graph for age against the income. How is age related to the income? And related to more graphs, we have it in the more code. So this is the correlation between the every variable that we have in our data set. So the more the number is negative, the more there is an inverse relation. The more the number of positive, then there is a positive relationship between the two variables. And if there is a zero, then there is no relationship between the two variables. So negative doesn't mean that there is no any relation or nothing relationship between the two variables. But when there is a negative one, then it is described like there is an inverse relationship between the numbers. So, and also I have mentioned here about this. So that's all. And here I have the graph for hours per week and income. So, and also a few more scatter plot that I have plotted here, which is education level and versus income. And going ahead with this, few more graphs that I have also pasted here, like the occupation versus income, how the occupation is related to the income. Based on that, I have the graph is there. And this is the basic mathematical formula behind the multiple linear regression. Linear regression is a model that is a single line, and that will plot on a graph on a data points. It will give us the predictions, and based on that we can also find it using the MSE's mean square error. Then we can find out the errors as well. So this is just a basic maths, and the linear regression goes with y is equals to mx plus c, which is the equation for single line. And like this. So we have dropped some columns which is not relevant, and then this is the basic EDA processes that I have done here. And this is my line of regression and the other data points. So this that's how model looks like for the linear regression. And then I have trained my model, and I have fit the X train and Y train. I have also did the train and test split on the upper part. So the model training is done here. And then these are my model predictions. The mean square error is 0.13. So 0.13 means 13% of the variance of the output is described by the input variables. So that's what mean squared error means. And the smaller the mean squared error is, the more the model is good. And the higher the mean square error is, it's bad for the model, because then the error is too much. And the smaller the mean squared error is, it's good for the model. So now I have did the model performance. So it goes with the OLS, because OLS is very famous to give the detailed description of how the performance work for any model. And going ahead with this, I have also did some more uh, processes for this, like propensity score matching, to check the difference, and to check because these are all the statistics to match the causality in our data set, or causality in our features between the variables. So we have these three variables, or we can say that three entities, like the ATE, which is average treatment effect. So there is so it will take the averages of all the variables that is present in the study. And the average treatment effect is on the control group is dependent on this will take the data from the control group, not from the treatment group, because we usually have two groups in the casualty, which is treatment group and the control group, and the next one is the treatment group. So that's how it is described into three parts. And here I have installed the casual inference, and I did the normal. I did fit the model here, and the casual model is in this step, and then printing the output for the casual model. So like this, and I have here presented all the variables and all the variables that I have chosen in the in the prior code to check whether it is good or not. And the detailed description of every variable is already there. And also the detailed description of ATE, ATC, and ATT, which I already discussed earlier, the control group and the treatment group. And yeah, and then next I have the directed acyclic graph, which is usually used to check, or usually used to see see the relationship between the variables. So I'll just straight away see you the result. This is my code for the nodes. I'll have these many nodes in my data set, and then this arrow means that the ages is related to the marital status, age is related to occupation, and then rest of the things. So I have also given the detailed description of DAG, age, marital status, and occupation and hours per week, how they are related to each other using the DAG. So DAG is also the representation of how the causality works in the machine learning model. It will show us how one variable is related to another variable and how another variable is related to another variable. Like I have shown in the previous, in the starting of the notebook, that A is related to B is related to C, and then A will be related to C. So it's a cyclic graph. So that's why this is named as a directed acyclic graph. And then this is the DAG for causal inference, and the arrow shows that hours per week is related to income like this. And here I have given all the description of how everything is working here in the DAG. And this is my conclusion, my references that I have used here, and my licenses. So thank you so much. Have a nice day.